Question 12. Sequence shown in graph can be written in function notation as, and we are given 4 options. Important thing here to understand is that like functions, sequence are also functions, but where the domain is set of natural numbers. Now just as you represent functions in different forms, sequences can also be represented in different forms. One of them is graph. So the graph here shows a sequence. Do you see these dots, right? So this kind of looks like a parabola, right? Now here, this is not a continuous graph. These are discrete values. So in sequences, you will always have discrete values. Reason being, it is not set of real numbers. It is always in the set of natural numbers, right? So sequences are discrete in nature. So we have distinct values, do you see? Separated out, like dots on the coordinate plane. Now here, you will notice that the question specifies sequence shown in the graph can be written in function notation. So we want the answer in function notation, not in any other format or notation or term. The answers given are, first one is in set notation, which is not the requirement. The second one is the general term, explicit formula. Third one is function notation. All the above actually represent the sequence some way or the other, but not in function notation. The only option C is in function notation, and therefore here the answer is C. Well, as you will notice in last 3 examples, the focus was on different types of notations, whether it is general formula or it is being represented by a recursive definition or by a function notation. You have to read the problem carefully to understand in which format the answer is required, because there are options and different ways of giving the same answer. Do you understand? And in one of the examples you also saw that the next term in a sequence could be different depending on what is generating it. Now here, let's look into this graph. The first point is -1, -3, right? This is -1 for us. Oh, sorry, +1, -3. This is -3 for us, okay? So I've written the points here, 1, -3. Second point is 2, -2. Third is 3, 1. Fourth is 4, 6. Fifth is 5, 13, right? So these are the points which are represented here, but they are not in function notation. Now this can be generated by the function notation formula. If I write n as 1, right? So what do we get as f of 1? So we'll write here f of 1 equals to 1 minus 1 square minus 3, which is -3, right? F of 2 equals to 2 minus 1 square minus 3, which is 2 minus 1 is 1. 1 square is 1. 1 minus 3 is -2. And let me write here f of 3. Okay, let's write here. F of 3 equals to 3 minus 1 whole square minus 3. 3 minus 1 is 2. 2 square is 4. 4 minus 3 is 1, right? This is it. And f of 4 equals to 4 minus 1 whole square minus 3, right? 4 minus 1 is 3. 3 square is 9. And 9 minus 3 is 6, right? So we get this point also. Similarly, f of 5. 5 minus 1 is 4. And 4 square is 16. 16 minus 3 is 13, right? So it matches the data. Here it is, right? For 5, we have 16, right? So all the points match the data. If the input is n as 1, 2, 3, 4, and 5, 1, 2, 3, 4, and 5, the output is what we generated, right? So -3, -2, 1, 6, and 13. The correct answer is option C. That's our answer. Okay, I hope you understand that we could find a sequence from the graph also. Thank you.